right, let's talk about compound inequalities. So that's just whenever you have more than one inequality at the same time. You graph them on the same number line, for now a number line, eventually you're gonna get to a whole Cartesian plane. But whenever you have multiple inequalities, that's a compound inequality. Imagine that. So on a number line, it would look something like this. Now, all you have to do is read what this one is, read what that one is, and since they're split up, you're going to put an or between them. So this is how we'd write it. X is less than or equal to -4. See the solid dot goes out to negative infinity. Or, because we're splitting it, X is greater than 1. Key thing about integral notation here, the way we write or is with the union symbol. It's a U. It looks like that. This is called the union symbol. It joins two sets together. And to solve them, solve the left part, solve the right part, take them in integral notation or on the graph, whatever you need to do. Let's try some. So notice we have this inequality or that inequality. Well, just solve them. Solve this one, solve that one. Now, let's just go ahead and solve it right here. 3x is less than or equal to 6, divided by 3. X is less than or equal to 2. Okay, don't forget your or. I'm gonna solve this one. Divided by 5, divided by 5, well, I'm done already. X is greater than 9. So here's what we got. X is less than or equal to 2, or X is greater than 9. So this is the number line they provided us. Kind of sucks. Move over here a little bit, I guess. 2, here it is. I'll put a solid dot on 2 because it's got the equality on it. Then over here on 9, I can put an open circle. Okay, less than, so I'm gonna go this way. So you could graph this whole thing at once, doesn't matter. And then this one's greater than. So I'm gonna go that way. No, that's terrible, whatever. You get the picture. And if you don't, well, figure it out. Integral notation, again, we're going to just do exactly what it says from left to right. Whenever we have a split, we're going to put a union. Negative infinity, don't forget the negative. I did that first time on the first one, my bad. Negative infinity all the way up to 2. Never include an infinity, so it's got a parenthesis. That's solid, so put a bracket. We're splitting. Stick a U up in there. And that's open. It kind of doesn't look open, but it's open. Let me make that a little better. Let me make it a little more clear that it's open. There we go. So it's starting at 9, and it doesn't include it, so I'm going 9 to infinity. Boom. So we got a closed set here, an open set here. All right. That's how we'd write it. Integral notation. That's how we'd graph it. Done. Next. Okay, let's look at this one. So I need to get my a by itself. So subtract 6, subtract 6. Negative 2a is less than 2. Divide by negative 2. So a, negative 1. I divided by negative. Don't forget to flip your direction. It's greater than negative 1. 4. All right, here we got a fraction, LCD, straight away. You could get the 1 over first, doesn't matter. But anytime you see a fraction, multiply by your LCD. To each and every term, don't forget what a term is, anything separated by addition, subtraction, or equal sign, or equality sign now. Okay. So I'm going to multiply 2 times a over 2 plus 2 times 1. That's less than, it's a positive 2, so I did not change my direction. 2 times negative 2. Those cancel on us with a plus 2 is less than negative 4. Subtract 2, that's a weird 2. Subtract 2, I get a is less than negative 6. Okay. So I'm going to start with this one. A is greater than negative 1. So I'm going to find negative 1 on here, put an open circle. This I'm going to try and keep it open. Be careful with my shading. And it's greater than that. So I'm going to go this way. Something like that. Or a is less than negative 6. So here's negative 6. And let me check something. Yeah, I'm good. Okay. And it's less than that. So I'm going this way. Okay. That's it. It's graphed. I didn't shade into my open circles on this time, so that's better. Stick it in interval notation. Furthest thing to the left is negative infinity. Don't forget, you have to use a parenthesis when dealing with infinities. Yes, I'm going to tell you every single time. Also doesn't include that union because we were jumping over here. Negative 1 to infinity. Open. So if we look at it, everything from negative 8 up to 6 doesn't include either one. Oops, sorry, negative 6. Dang it. So negative infinity to negative 6 doesn't include either one of those. Union, negative 1 to infinity, doesn't include either one of those. Next. So we got some fractions. So again, when we're dealing with LCD, we're working these two problems entirely and completely and totally separately. So this problem doesn't mess with this problem. So I'll do this. LCD on this first one is obviously negative 3 because that's my only denominator. So I take negative 3 and I multiply it each term. I don't know if I'm enough room. 8 minus x over negative 3. Now I'm going to less than or equal to, no, I multiply by negative. Flip it. Greater than or equal to negative 3 times negative 5. Whenever we flip it, we just change the direction. The equality doesn't change, only the direction of your inequality part. So if it was less than, now it's going to be greater than. If it's greater than, then it's going to be less than. Whenever we multiply by negative, it just changes direction. These cancel. 8 minus x greater than or equal to 15. Subtract 8. Subtract 8. Negative x greater than or equal to 7. Get x by itself, I have to divide through by negative 1. X is greater than, no, we divided by negative 1. Flip it, less than or equal to negative 7. So we had to flip this one twice. That can happen. You can flip it twice, 3 times, 27 times. Pay attention. Anytime you divide or multiply by a negative number, you must change your direction right then and there. All right, let's solve the other side. LCD on this one is going to be a 2. So I'm going to do 2 times the 5 minus 2 times the 3/2 x, blah, 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 less than 2 times the negative 1. I'm just multiplying each thing by 2. So now LCD is 2, I'm multiplying by 2. So 5 minus 3 halves x less than -1. All I did was multiply each thing by a +2. Multiply by positive, so I did not change my direction. 10, these 2's will cancel. Minus 3x is less than -2. Subtract 10 from both sides. Subtract 10 from both sides. -3x is less than -12. Divide through by a -3. So I'm left with x. I divided by a negative, so I flip the direction. 4, x is greater than 4. So here's what I got. X is less than or equal to -7, or x is greater than 4. Graph them. So less than, so that goes out to -infinity. Here's -7 right here. It does include it because it's got the equality on it. So I'm gonna do that. Greater than 4, 4 is over here, does not include it, goes out this way. In our notation, I'll do it in purple so we don't get confused with all this mess. -infinity to -7, bracket, union, parentheses, 4, infinity. Always, always, always. Infinities are in parentheses. You cannot include them. That's it. Done. That's your ors. Now we're going to look at ands. So anytime we have an or, we use a union symbol. Let's see what happens with an and. All right, here we go. If we look at this, we've got the intersection of two things because it's an and. It has to be true. This first part has to be true, and the second part has to be true. So usually that's going to make like a sandwich kind of thing. So here's how we'd write this. X is greater than or equal to -2. Now you can see that. And x is less than 5. So that's this line right here that's shaded is the solution to all the values that are bigger than -2 or equal to -2 and smaller than 5. So if you take any number in this set right here, it will satisfy both of these conditions. So if I look at that in interval notation, can you guess? Can you guess? Just stick some brackets in between. Boom. We got bracket, -2, comma 5, parentheses. Included, not included. Bracket, parentheses. We're starting at -2, we're ending at 5. No infinities here. We don't have to have infinities every time. See? Right here we don't have an infinity because it doesn't go on forever. Now, a lot of times we shorten this because it's just convenient to do so, and it saves us some work. We shorten that to look like that. We combine them. Let's see exactly what happens. So x is greater than or equal to -2. That would mean that -2 is less than or equal to x, right? The thing on the left is bigger than the thing on the right. So if I were to rewrite that, I could read it from right to left. X is greater than or equal to -2, or left to right, -2 is less than or equal to x. Same thing. X is less than 5. Well, I literally have that right here, just hide this part, and it says x is less than 5. So that part doesn't change. Whenever we're making them a sandwich, whenever condensing them, it always needs less thans or less than or equal to's. Don't try and put the greater thans. That's not standard. We use the less thans for our condensed form because that's making us read from left to right. -2, then x, then 5. So if it's written like this, solve both of them, graph it in a rotation. If it's written like this, where you can do it all at once, just instead of 2 sides, you have 3 sides of your equal sign, except an inequality sign here. Let's just look at it. Let's do it. First one, subtract 1. 2w less than or equal to 10, divide through by 2, w is less than or equal to 5. Okay, and subtract 1, negative 5w less than 40, divide by a negative 5, w is greater than 8, and it's a negative 8. So here's what we got. W is less than or equal to 5, w is greater than negative 8. My suggestion is to plot both of these first. So less than or equal to 5, that's going to be a solid dot on 5. And it's less than, so I'm going to shade a little bit to the left. And x is greater than negative 8. So here's negative 8. Does not include it. Let me make that bigger. And it's greater than, so it's going this way. Let me look. Yeah, they're going to meet in the middle. So it's everything in between them. Okay. Whenever we're doing these, there are possibilities of no solution. If we're doing an OR, there's a possibility of all real numbers. At the very end of this, I'm going to stick some of those examples on here so you can see what's going on. Integral notation. Negative 8 does not include it. 5, it does include it. That's it. Just read the graph left to right. All right, here we have a sandwich. So I'm going to do what I do to one side, which we start in the middle, to all sides. I add 2. If I do it to this side, I have to do it to the left side, the middle side, and the right side. Okay, that's 30, greater than negative 10m, less than or equal to negative 5. Divide through by a negative 10. What I do to the middle, I got to do to everybody. All right, I divided by a negative, so I have to flip the direction of my symbols. It was greater than, now it needs to be less than. Oh, hey, that's what we wanted anyway. M is less than or equal to a half. Remember, whenever we have a sandwich, standard notation is less than symbols. We got less than's, we don't have to switch it around. We didn't have less than's, we just have to rewrite it again with less than symbols. Okay. It's a sandwich, it's really easy to graph. You start here and you end there. Negative 3, that's like here. It does not include it. Half. Oh, wait, where's a half? Between 1 and 2. Right here. It does include it, so put a solid dot there in the middle of them. And shade. So go inside your circle. You can make a bigger dot if you want to, it doesn't matter. Just as long as you know and I know what you're talking about. So don't put the dot on 1, don't put the dot on 2, put them between them. That's good enough. Try in the middle-ish. That's the graph. That's a negative 3. That's a half. That's a bracket. That's it. Last one, I think. Yeah, last one, and then I'm going to talk about all real numbers and no solution looking ones. I've got a fraction, so LCD, big whoop. I'm multiplying through by a negative 2. So negative 2 times this thing, less than or equal to, nope. We're multiplying by a negative, change the direction. Greater than or equal to negative 2 times this thing. It's greater than negative 2 times that thing, which is also a negative 2. Do what you got to do to it. These cancel. 10 is greater than or equal to 12 minus x, which is greater than a 4. Subtract 12. Negative 2 greater than or equal to negative x, greater than, that's a minus sign, not a greater than or equal to, so be careful. Don't misread your handwriting, I almost did. Negative 8. And then I divide through by a negative 1 to all three sides. So I get 2 is, no, we've divided by a negative, change direction. Oh, good. It's how we need it. It's got less than in there. All right, so let's just graph it and be done. Well, and my interpretation. So 2, we got a solid dot there. And 8, we got a open dot there, and it's everything between them. All right, in our notation, bracket 2, comma 8, and they could both have brackets. That would be a closed set. So if this was greater than or equal to, it would be bracket and bracket. So it's possible. We didn't do any, but it's possible. And that's a wrap on that. So real quick, let's talk about how we could have all real numbers as an answer. Let's say I have x is less than 5 or x is greater than 0. Let's see what that looks like. I'll draw a nicer line right here. So this number 9 goes on forever, blah, 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 whatever. So I'm gonna stick my numbers on there. Here's 0, here's 5. X is less than 5, so I'm gonna do this one in blue. X is greater than 0, I'm gonna do that one in red. So yeah, so this would be an open circle. Yeah, that's an open circle. But notice how the less than 5 part went through 0, so it's grabbed it because it's an or. This is gonna include the 5. So if I look at it, this part's everything bigger than 0, so that includes the 5. This part's everything less than 5, so that includes the 0, so that includes everything. So all real numbers would be my answer. And of course, you could put the real number symbol. And in interval notation, we'd write that as, well, negative infinity to positive infinity. 1 second. Okay, real quick. Let's finish this off. That's all real numbers. Now let's talk about, Alana, leave the mirror alone. Let's talk about no solution. Sorry, hang on, guys. All right, no solution, last one. If x is less than 5 and x is greater than x is greater than 0. Let's look at what that would look like. Wait, sorry, that's perfectly possible. Let's say it was the other way around. Let's say x is bigger than 5 and smaller than 0. Let's see how that would look. So it's an and, so we gotta make it true for both of these. So here's 0 over here, and I need something that's smaller than it. So let's go that way. Here is 5 over here, and I need something that's bigger than that. So it would go that way, but let's see what's bigger than 5 and smaller than 0. There's nothing. There's nothing that's true for this. So there's no graph. It would just be nothing on the graph. It would be a blank graph. And our answer would be no solution. And you might see that in several ways. You can see the empty set. That's two curly brackets, just like that. You might see the empty set notation. And an inner notation, well, there's just wouldn't be any. Okay, that's it. Done. See you next time.